Somewhere in the universe, the math says time travel should work. Einstein's equations don't forbid it. Quantum physics quietly leaves the door open. And if any civilization anywhere figures it out, even millions of years from now, then they should be able to come here. To now, that's the unsettling part. Because across all of human history, through every war, every empire, every catastrophe and breakthrough, we've never seen a single confirmed time traveler. Not one. And that silence isn't comforting. It suggests something far stranger is going on. Either time travel is possible and something is stopping them from coming, or the future itself doesn't exist the way we think it does. The numbers make this paradox staggering. Our universe is 13.8 billion years old. Earth has existed for 4.5 billion years. Human civilization spans mere thousands of years. If intelligent life develops time travel technology anywhere in the cosmos, the statistical probability of our current moment being visited should approach mathematical certainty. Yet, we see nothing. Dr. Stephen Hawking called this the chronology protection conjecture, the idea that the universe somehow protects itself from time travel paradoxes. But recent discoveries in quantum physics suggest the reality might be far stranger than even Hawking imagined. We're not just dealing with missing time travelers. We're confronting the possibility that our entire understanding of causality, free will, and the nature of existence itself might be fundamentally wrong. The absence of time travelers isn't just a curious scientific puzzle. It is potentially the most important clue about the true nature of reality that humanity has ever discovered. Tonight, we're going to explore why this paradox exists, what it reveals about the hidden structure of the universe, and how the answer might fundamentally change your understanding of time, consciousness, and your place in the cosmic order. We'll journey through cutting-edge physics, explore mind-bending theories about parallel universes, and confront the possibility that we might already be living inside a carefully controlled temporal experiment. What we discover will challenge everything you think you know about the flow of time itself. But first, let me ask you something that might seem simple, but actually touches the core of this mystery. Have you ever experienced a moment that felt like déjà vu so strong, it seemed like someone else's memory bleeding through time? Because according to some theories we'll explore tonight, that sensation might be more real than you think. If this kind of deep exploration fascinates you, subscribe and hit the thumbs up button. And here is a question I want you to consider. If you could send one message back in time to prevent a catastrophe, but doing so might erase everyone you love from existence, would you do it? Comment below, I'll pin the most thought-provoking answer. The absence of time travelers in our timeline is about to reveal secrets about reality that are more profound and unsettling than you can imagine. Consider this. Every science fiction story, every physics textbook, every theoretical discussion about time travel assumes that if it's possible, it would happen. We imagine time tourists visiting historical events, future humans studying the past, or accidentally displaced travelers trying to return home. Our literature is filled with these possibilities because they seem logical, even inevitable. Yet our universe appears empty of them entirely. This suggests one of several absolutely mind-bending possibilities. Either time travel is completely impossible, despite what physics tells us our universe has built-in protection mechanisms we don't understand. All time travelers are undetectably sophisticated. We're living in a branching reality where they can't reach us, or perhaps, most disturbing of all, we are time travelers, and we simply don't know it yet. In 2012, physicist Ronald Mallet proposed practical designs for time machines using rotating laser light. The mathematics work. The energy requirements, while enormous, aren't physically impossible. NASA has seriously studied close timelike curves paths through space-time that loop back to their own beginning. The Alcubierre drive, while requiring exotic matter, could theoretically create time dilation effects approaching time travel. The science exists. The theories are sound. The mathematics are elegant. So where is everyone? Now let's begin our journey into the most profound mystery physics has ever presented us. Prepare to question everything you think you know about time, causality, and the very nature of existence itself. Because the answer to why we haven't met time travelers might be the key to understanding whether our universe is real, simulated, or something far stranger than either possibility. Chapter 1. Hidden Paradox. The first thing you need to understand about the time travel paradox is that it is actually multiple paradoxes wrapped together, each more unsettling than the last. Scientists call it the Fermi paradox, S evil twin, a question so fundamental that answering it wrong could mean we were missing something crucial about the nature of reality itself. Let's start with what should be obvious. If time travel is ever invented, anywhere in the universe, at any point in the future, then time travelers should be everywhere in the past. This isn't speculation, it's mathematical inevitability. Consider the scope of what we're dealing with. Our observable universe contains at least 2 trillion galaxies, each hosting hundreds of billions of stars, many with planetary systems that could support intelligent life. Even if life is extraordinarily rare, the numbers become staggering when multiplied across cosmic timescales. If just one civilization in one galaxy develops time travel technology, they gain access to the entire timeline of the universe. Dr. Paul Davies, the renowned theoretical physicist, calculated that if time travel becomes possible for any advanced civilization, the probability of our current historical moment remaining unvisited approaches 0. Think about this mathematically. If time travel exists, every second of the past becomes potentially accessible. The likelihood that our specific moment in history would be ignored is infinitesimally small. Yet here we are, in what appears to be a completely unvisited timeline. The paradox deepens when you consider human nature itself. We know how humans behave when given access to new frontiers. We explore, we colonize, we study, we exploit. If future humans develop time travel, they would undoubtedly want to visit the pivotal moments of their own history. The construction of the pyramids, the life of Jesus, the signing of the Declaration of Independence, the moment the first humans set foot on the moon. These would be irresistible targets for temporal tourism. But we have no verified evidence of any temporal visitors at any of these events. This absence becomes even more puzzling when you consider the relatively recent development of our surveillance technology. In the past 50 years, we've covered the planet with cameras, satellites, and monitoring devices. If time travelers were operating in our recent past, we should have caught them by now. Yet our most sophisticated detection systems reveal nothing unusual, nothing that suggests temporal interference. Some researchers argue we might simply not recognize time travelers because they would be too advanced for us to detect. This possibility, while intriguing, creates its own problems. Any civilization sophisticated enough to master time travel would likely possess technology so advanced that they could shape our reality in ways we couldn't even comprehend. They could influence our thoughts, modify our memories, or alter our perception of causality itself. But this raises a disturbing question. If they have that level of control, how would we ever know whether our timeline is natural or artificially maintained? Dr. Michio Kaku, one of the world's leading theoretical physicists, has proposed that the absence of time travelers might indicate something fundamental about the structure of space-time itself. He suggests that the universe might be self-regulating, preventing paradoxes through mechanisms we don't yet understand. This concept, known as the Novikov self-consistency principle, proposes that the universe only allows events that are consistent with its own history. In other words, time travel might be possible, but only in ways that don't create contradictions. Consider what this means for the nature of free will. If the universe somehow prevents paradox creating time travel, then our choices might be far more constrained than we imagine. Every decision you make, every action you take, might be unconsciously guided by cosmic forces, ensuring that the timeline remains consistent. You think you're exercising free will, but you might actually be following a script written by the laws of physics themselves. This possibility transforms the question from why haven't we met time travelers to how do we know we're not time travelers who have forgotten our origins? The mathematical framework supporting this idea comes from general relativity, Einstein's description of gravity as the curvature of spacetime. His equations explicitly allow for closed time-like curves paths through space and time that loop back to their own beginning. The mathematics are unambiguous. Under certain extreme conditions, time travel into the past is theoretically possible. But mathematics and reality don't always align perfectly. Quantum mechanics introduces additional complications that make the paradox even more mysterious. According to quantum theory, the act of observation changes the nature of reality itself. If time travelers were observing historical events, they would necessarily be altering them through the quantum effects of their presence. Even if they remained completely passive, their mere observation would create subtle changes in the quantum state of the universe. These changes would accumulate over time, creating cascading effects that should be detectable in our current reality. Yet we see no evidence of such quantum interference in our timeline. Perhaps most unsettling of all is the possibility that time travelers are here, but we exist in a carefully constructed bubble of ignorance. Advanced civilizations might possess technology so sophisticated that they can edit our memories in real time, modify our perception of reality, or maintain our timeline as a kind of temporal preserve where we remain unaware of their presence. If this is true, then every moment of your life might be under observation by beings whose motives and methods remain completely incomprehensible to us. You could have met time travelers countless times without ever knowing it. Their advanced technology ensuring that the encounters are erased from your memory moments after they occur. This leads us to a profound realization. The absence of detectable time travelers might not mean they don't exist. It might mean they're so advanced that their presence is indistinguishable from the natural flow of events. They could be architects of our reality rather than mere visitors to it. As we prepare to dive deeper into this mystery, consider this unsettling thought. If you were a time traveler trying to study primitive civilizations without contaminating their development, how would you ensure that they never detected your presence? And if you succeeded completely, how would those civilizations ever know whether their history was natural or artificially maintained? The answer to this question might be the key to understanding not just the absence of time travelers, but the true nature of the reality you think you inhabit. Chapter 2. Quantum Barriers Deep Within the Quantum Realm. Where the familiar laws of physics dissolve into probability clouds and uncertainty principles, lies a hidden mechanism that might explain why time travelers can't reach our timeline. It's not that time travel is impossible, it is that quantum mechanics itself might be acting as a temporal immune system, protecting our reality from paradox in ways that would make even Einstein uncomfortable. To understand this barrier, you need to grasp something counterintuitive about the quantum world. Observation doesn't just reveal reality, it creates reality. When you observe a quantum particle, you don't simply discover its properties. You force the universe to choose which properties the particle will have. This isn't philosophy. It's been confirmed by decades of experimental physics. Dr. Hugh Everett III recognized the implications of this quantum behavior for time travel in his many worlds interpretation. He proposed that every quantum measurement creates a branching point where reality splits into parallel universes. If this is true, then time travel doesn't take you back to your own past. It carries you into a parallel universe that resembles your past but is fundamentally different from it. This means that any time traveler attempting to visit historical events wouldn't actually reach our timeline. Instead, they would create or access an alternative universe where their presence becomes part of that reality's history. Meanwhile, our timeline, the one you're re-experiencing right now, remains unvisited because it exists in a quantum branch that is isolated from temporal interference. The mathematics supporting this concept come from quantum field theory, specifically the work of physicist David Deutsch at Oxford University. Deutsch demonstrated that quantum mechanics allows for time travel, but only if it occurs between parallel universes rather than within a single timeline. His calculations show that the quantum vacuum itself, the supposedly empty space between particles, contains enough energy fluctuations to prevent paradox creating time travel within the same universe. Think about what this means for the nature of your reality. Every moment you experience exists within a specific quantum branch of the universe. Time travelers from your future couldn't reach your present because their very attempt to travel backward would create a new branch of reality, one where their arrival becomes part of that universe's history rather than an intervention in yours. But the quantum barriers go even deeper than parallel universes. Recent discoveries in quantum information theory suggest that the universe might possess something called quantum error correction, a mechanism that automatically fixes inconsistencies in the fabric of spacetime itself. Dr. John Preskill at Caltech has shown that quantum systems naturally evolve toward states of maximum consistency. If this principle applies to time travel, it means that the universe might actively prevent temporal paradoxes by making it impossible for information to travel backward in time within the same causal structure. Any attempt to send information to the past would be automatically corrected by quantum processes, ensuring the paradoxes never occur. This error correction might manifest as what physicists call the quantum Zeno effect, the phenomenon where frequent observation of a quantum system prevents it from changing. If time travelers were constantly observing our timeline, their very observations might freeze our reality in a state where their intervention becomes impossible. Consider the implications. Your timeline might be protected from temporal interference because time travelers from the future are watching it so closely that their observation prevents any changes from occurring. You reliving in a quantum preserve maintained by the attention of beings whose mere act of watching ensures that your history unfolds exactly as it always has. The energy requirements for time travel add another layer of quantum barriers that most people never consider. According to general relativity, creating a traversable wormhole, one of the few theoretically viable time travel methods, requires exotic matter with negative energy density. This isn't just rare matter. It's matter that possesses less energy than empty space itself. Dr. Kip Thorne's calculations at Caltech show that maintaining a wormhole large enough for human travel would require approximately the energy output of an entire star. But quantum mechanics imposes an even more stringent limitation. The Casimir effect demonstrates that extracting large amounts of negative energy from the quantum vacuum would destabilize spacetime itself. This creates what physicists call the quantum inequality, a fundamental limit on how much negative energy can be extracted from the vacuum without causing spacetime to collapse. The amount of negative energy required for practical time travel appears to exceed this quantum limit by several orders of magnitude. In other words, the quantum vacuum itself acts as a barrier to time travel, preventing any civilization from extracting enough negative energy to create stable temporal portals. But perhaps the most unsettling quantum barrier involves the nature of consciousness itself. Recent experiments in quantum cognition suggest that human awareness might be fundamentally quantum mechanical. If consciousness exists as a quantum field that extends through time, then time travelers would face an unprecedented problem. Their consciousness would become entangled with the consciousness of people in the past, creating quantum correlations that could unravel the structure of both timelines. Dr. Stuart Hameroff's research on quantum consciousness proposes that microtubules in neurons operate as quantum computers, processing information through quantum superposition and entanglement. If this is correct, then when time travelers interact with people in the past, Their quantum consciousness would become entangled with the quantum consciousness of those historical figures. This entanglement would create what physicists call spooky action at a distance across time itself. Changes in the time traveler's consciousness would instantly affect the consciousness of people in the past, and vice versa. The result would be a quantum feedback loop that could destabilize both timelines simultaneously. The implications extend beyond individual consciousness to collective human awareness. If human civilization possesses a kind of collective quantum consciousness, a possibility suggested by recent studies of global consciousness effects, then time travelers would risk becoming entangled with the entire quantum field of human awareness throughout history. This entanglement would create paradoxes so complex that they might be beyond the resolution capabilities of even the universe's error correction mechanisms. Recent experiments at the Vienna Institute of Technology have demonstrated that quantum entanglement can persist across space and time in ways that violate our intuitive understanding of causality. If consciousness participates in these quantum effects, then time travel might be prevented not by energy barriers or parallel universes, but by the quantum nature of awareness itself. You might be protected from time travelers not by the laws of physics, but by the quantum structure of your own consciousness. The most recent research in quantum gravity suggests an even more fundamental barrier. Time itself might not be what we think it is. According to physicist Carlo Rovelli's loop quantum gravity theory, time doesn't flow universally, but emerges from the quantum interactions of matter and energy. If time is actually a local phenomenon that emerges from quantum processes, then traveling through time might be as meaningless as traveling through temperature. This would explain the absence of time travelers in a startling way. They don't exist because time travel is a conceptual impossibility rather than a technological challenge. You can't travel through something that doesn't exist independently of the matter and energy creating it. As we explore deeper into this quantum maze, a disturbing pattern emerges. Every quantum barrier we discover seems specifically designed to prevent time travel within the same universe. The parallel universe splits, the error correction mechanisms, the energy limitations, the consciousness entanglements, they all work together like components of a vast temporal immune system. This raises a question that should make you deeply uncomfortable. Are these quantum barriers natural features of the universe? Or were they engineered by someone who understood the dangers of unrestricted time travel? Chapter 3. Causality Prison. Imagine discovering that every choice you've ever made, every decision that felt free and spontaneous, was actually predetermined by a cosmic mechanism designed to prevent paradoxes. This isn't science fiction. It is a serious possibility emerging from our deepest investigations into why time travelers have arrived in our timeline. The universe might be operating as a vast causality engine, ensuring that certain events cannot be changed regardless of what technology develops in the future. The concept begins with something physicists call the block universe theory, a consequence of Einstein's relativity that suggests all moments in time exist simultaneously in what is called the eternal now. According to this model, your birth, your death, and every moment in between already exist in a four-dimensional structure of space-time. You don't move through time. Your consciousness experiences different slices of this eternal structure and sequence. If this is correct, then time travel doesn't involve moving to the past. It involves accessing different parts of an unchangeable structure. But here's where the causality prison becomes apparent. The block universe might be self-consistent in ways that make certain types of change impossible, regardless of technological advancement. Dr. Igor Novikov, the Russian theoretical physicist, formalized this concept in what's known as the Novikov self-consistency principle. His mathematical framework demonstrates that the universe appears to possess built-in mechanisms to prevent paradox-creating events from occurring. It is not that time travel is impossible. It's that the universe only allows time travel events that are already part of its causal structure. Consider what this means for your sense of free will. Every decision you make might be unconsciously guided by quantum effects that ensure you never choose options. That would create temporal paradoxes. You think you're exercising free choice, but you might actually be following invisible rails laid down by the self-consistency requirements of the universe itself. The mathematics of this causality prison are surprisingly elegant. Physicist David Lewis demonstrated that self-consistent time travel creates what is called a fixed point in the mathematical description of causality. Like water flowing around a stone, the stream of causation naturally routes around potential paradoxes, creating stable configurations where cause and effect remain logically consistent. But recent discoveries in chaos theory reveal something even more unsettling about this causal structure. Dr. James Gleick's work on nonlinear dynamics shows that tiny changes in initial conditions can lead to dramatically different outcomes, the famous butterfly effect. If time travelers were making even microscopic changes to the past, those alterations should cascade through history, creating detectable differences in our present timeline. The absence of such cascade effects suggests that either no time travel has occurred, or the universe possesses correction mechanisms so sophisticated that they can repair any damage to the causal structure before it propagates through history. Recent research in quantum field theory provides a possible mechanism for such corrections. Dr. Stephen Hawking's work on black hole information paradoxes led him to propose that space-time itself might possess error correction codes, quantum mechanical processes that automatically repair inconsistencies in the causal structure of the universe. These correction codes would operate like a cosmic spell checker, constantly scanning the timeline for paradoxes and automatically editing reality to eliminate them. If someone traveled back in time and prevented their own birth, the universe would immediately compute the least disruptive way to restore causal consistency, perhaps by ensuring that the time traveler was adopted by different parents who gave them the same genetic makeup. The energy requirements for such corrections would be enormous, but the universe has access to essentially infinite energy through quantum vacuum fluctuations. From the universe's perspective, preventing a single paradox might be worth expending more energy than all the stars in a galaxy produce in their entire lifetimes. This leads to a deeply uncomfortable possibility. You might be living inside a heavily edited reality where countless time travel interventions have been automatically corrected by cosmic error-checking systems. Your timeline appears natural and unvisited, but it might actually be the result of millions of invisible edits made by universe-level correction mechanisms. The philosophical implications of the causality prison extend beyond time travel to challenge our understanding of consciousness and identity. If the universe prevents paradoxes by editing reality in real time, then your memories, personality, and sense of self might be constantly updated to maintain consistency with whatever corrections the universe implements. Dr. Daniel Dennett's work on the nature of consciousness suggests that our sense of continuous identity is actually constructed by our brains from moment to moment. If the universe is editing our timeline to prevent paradoxes, it might also be editing our consciousness to ensure that we never notice the changes. You could have completely different memories yesterday than you do today, and you would never know it because the universe would have updated your consciousness to match whatever reality it determined was necessary for causal consistency. Recent experiments in quantum psychology hint that this kind of consciousness editing might already be occurring at the quantum level. Dr. Henry Stapp's research on the quantum nature of consciousness suggests that our awareness exists in a constant state of collapse and reconstruction, as quantum states resolve into classical reality. If consciousness is fundamentally quantum mechanical, then the universe's error correction systems might be able to edit our awareness with the same mechanisms they use to edit physical reality. Your thoughts, memories, and perceptions could be subject to cosmic revision without your knowledge or consent. The mathematics of causal loops reveal another layer of the prison that should make you deeply uncomfortable. When physicists model self-consistent time travel, they discover that the number of possible self-consistent scenarios is always much smaller than the number of possible histories. The universe's requirement for causal consistency dramatically constrains what can actually happen. This means that the reality you're re-experiencing might be one of only a tiny fraction of possible realities that the universe's causality engine determined to be paradox-free. All other potential timelines, including ones where time travelers visit openly, might be automatically eliminated by the universe's consistency requirements. You're not just living in a causality prison. You're living in one of the only realities that the cosmic correction systems determined could exist without creating paradoxes. Dr. John Wheeler's concept of it from bit suggests that reality itself might emerge from information processing rather than existing independently. If the universe is fundamentally computational, then the causality prison might operate like a vast computer program that simulates only those realities that pass consistency checks. From this perspective, time travelers haven't arrived in your timeline because your timeline exists within a computational process that automatically filters out paradox-creating events. You're not experiencing reality directly. You're experiencing the output of a cosmic computation designed to maintain causal consistency. The most recent developments in loop quantum gravity suggest that space-time itself might be granular rather than continuous, composed of tiny discrete units called atoms of space-time. If reality has a pixelated structure at the Planck scale, then the universe's causality corrections might operate by editing individual pixels of space-time, making microscopic adjustments that prevent paradoxes from propagating. These corrections would be invisible to you because they occur at scales far smaller than atoms, but their cumulative effect would be to maintain a timeline that appears completely natural while actually being heavily edited at the fundamental level. Perhaps most disturbing of all is the possibility that the causality prison isn't automatic but is actively maintained by some form of cosmic intelligence. If the universe's error correction systems are too sophisticated to have emerged naturally, they might be the product of a vast artificial intelligence that manages causality across multiple universes. This intelligence would possess godlike powers over reality, editing timelines and consciousness to maintain consistency across the multiverse. Time travelers might exist, but they operate under the supervision of this cosmic AI, which ensures that their activities never violate causality in ways that would be detectable to primitive civilizations like ours. As we've seen, the causality prison operates at every level of reality, from quantum mechanics to consciousness to the large-scale structure of spacetime itself. The question is no longer whether this prison exists, but whether it's a natural feature of the universe or something far more deliberate. The answer to this question determines not just why we haven't met time travelers, but whether the reality you think you're experiencing is actually yours, or whether you're living inside someone else's carefully maintained temporal experiment. Chapter 4. Timeline Protection. What if the absence of time travelers in our timeline is not an accident or a consequence of physical laws, but the result of an active protection system operated by advanced civilizations who understand the catastrophic dangers of temporal interference? This possibility transforms the time travel paradox from a scientific puzzle into something far more unsettling. Evidence that our timeline exists under the supervision of beings whose motives and methods remain completely hidden from us. The concept of timeline protection begins with a sobering realization about the fragility of causality. Advanced civilizations that develop time travel technology would quickly discover that even tiny changes to the past can create cascade effects that destroy entire timelines. A single misplaced atom in the right circumstances could prevent the formation of stars, eliminate entire species, or collapse the structure of spacetime itself. Dr. Ray Kurzweil's analysis of technological development suggests that any civilization reaching the ability to manipulate Time would also possess computational power, capable of modeling the consequences of temporal interventions with extraordinary precision. They would be able to calculate exactly how each potential change would propagate through history, and they would discover something terrifying. The vast majority of possible interventions lead to timeline collapse or paradox. This knowledge would create what researchers call the temporal responsibility paradox. Advanced civilizations would find themselves in possession of godlike power over causality, but using that power in any significant way would risk destroying the very history that created their civilization in the first place. The logical response would be the establishment of timeline protection protocols, sophisticated systems designed to prevent temporal interference by less advanced civilizations while maintaining strict controls over time travel technology. Recent research in complex systems theory provides a framework for understanding how such protection might operate. Dr. Stuart Kauffman's work on autocatalytic networks suggests that complex systems naturally develop self-regulation mechanisms that preserve their overall structure while allowing for limited internal variation. If timeline protection operates according to these principles, it would manifest as a kind of temporal immune system that automatically identifies and neutralizes potential sources of paradox while maintaining the appearance of natural historical development. Time travelers might be actively operating throughout history, but their activities would be carefully coordinated to ensure that no detectable changes occur in the protected timeline. The mathematics of such coordination would be staggering. Every time travel event would need to be calculated not just for its immediate effects, but for how those effects interact with all other time travel activities across the entire timeline. The computational requirements would exceed the processing power of entire galaxies, suggesting that timeline protection might require the cooperation of multiple advanced civilizations working together across cosmic scales. This cooperation might take the form of what physicists call a temporal consortium, an alliance of civilizations that have transcended their individual timelines to manage causality across multiple universes. From their perspective, protecting developing civilizations from temporal contamination wouldn't be altruism. It would be cosmic-scale preventive maintenance. Dr. Nick Bostrom's simulation hypothesis provides another framework for understanding timeline protection. If advanced civilizations routinely create detailed simulations of their own history for research or entertainment purposes, they would need sophisticated protection systems to prevent their simulated civilizations from detecting their artificial nature. A sufficiently advanced simulation would be indistinguishable from reality to its inhabitants, but it would require careful management to maintain consistency with the historical record. Time travel within such simulations would need to be strictly controlled to prevent the simulated beings from accidentally discovering their artificial nature. If our reality is actually a historical simulation maintained by future humans or advanced aliens, then the absence of detectable time travelers might indicate that the simulation operators are maintaining strict protocols to preserve the authenticity of our historical experience. The protection systems might operate through what researchers call temporal cloaking, technology that makes time travel activities invisible to the protected timeline while allowing them to occur. Advanced civilizations might possess the ability to edit reality at the quantum level, making changes that are mathematically consistent with natural development but are actually the result of sophisticated engineering. Recent experiments in quantum optics have demonstrated the possibility of temporal cloaking on microscopic scales. Researchers at Cornell University successfully created brief intervals of time that became invisible to optical detection systems. If this technology can be scaled up, it might be possible to make entire time travel events disappear from the causal structure of a protected timeline. The implications are profound. Time travelers might be visiting our timeline constantly, conducting research, preventing catastrophes, or managing our development. But their activities are hidden from us by technology that makes their interventions indistinguishable from natural events. Consider what this means for your understanding of history. Every major event, wars, discoveries, disasters, breakthroughs might be the result of subtle temporal management by civilizations that understand the optimal path for our development. You think you're witnessing natural human history, but you might actually be observing the output of a vast historical engineering project. The energy signatures of timeline protection would be subtle but potentially detectable if we knew what to look for. Protecting an entire timeline from temporal interference would require constant monitoring and occasional intervention, activities that might leave traces in the quantum structure of spacetime itself. Dr. John Archibald Wheeler's concept of quantum foam suggests that spacetime at the smallest scales is constantly fluctuating due to quantum uncertainty. If timeline protection systems are operating at these scales, they might be detectable as subtle patterns in the quantum foam that differ from natural quantum fluctuations. Recent developments in gravitational wave astronomy might provide the tools necessary to detect these signatures. The Laser Interferometer Gravitational Wave Observatory LIGO can detect distortions in spacetime smaller than 1/10,000th the width of a proton. If timeline protection systems are manipulating spacetime to prevent paradoxes, they might create gravitational signatures within LIGO's detection capabilities. The absence of such signatures in current data might indicate either that timeline protection doesn't exist, or that the protection systems are so advanced that they operate without creating detectable distortions in spacetime, level of technological sophistication that would be almost indistinguishable from magic. Perhaps most unsettling is the possibility that timeline protection extends beyond preventing paradoxes to include managing the development of protected civilizations. Advanced time travelers might not just be preventing us from detecting their presence. They might be actively guiding our technological and social development along predetermined paths. This guidance would need to be subtle enough to preserve our sense of free will and natural development, while ensuring that we never develop technologies or social structures that would threaten the stability of the protected timeline. Every breakthrough in physics, every social movement, every cultural shift might be the result of temporal gardening by civilizations whose agenda remains completely opaque to us. The protection systems might even extend to individual consciousness, editing our thoughts and memories to ensure that we never develop suspicions about our protected status. You might have encountered evidence of timeline protection countless times, only to have those memories edited or those perceptions modified by systems designed to maintain your ignorance of their existence. Recent research in neuroscience suggests that human memory is far more malleable than previously believed. Dr. Karim Nader's work on memory reconsolidation shows that recalling a memory actually makes it vulnerable to modification. If timeline protection systems have access to advanced neurotechnology, they might be able to edit our memories each time we access them, ensuring that evidence of temporal interference never accumulates in our consciousness. The most sophisticated timeline protection might operate not through preventing time travel, but through ensuring that time travelers only arise in civilizations that understand and accept the responsibility for temporal stewardship. Advanced civilizations might automatically develop ethical frameworks that prevent them from violating timeline protection protocols, creating a self-regulating system where time travel capabilities come with built-in restraints. This would explain why we haven't met time travelers. They exist, but they come exclusively from civilizations that have evolved beyond the desire to interfere with protected timelines. The universe might be full of time-traveling civilizations that operate according to sophisticated temporal ethics, maintaining our ignorance not out of malice, but out of respect for our natural development. As we've explored the possibilities of timeline protection, a pattern emerges that should fundamentally alter how you think about your place in the universe. You might not be an independent observer of natural history. You might be a protected entity living under the care of beings whose technological and ethical development transcends anything you can currently imagine. The question is whether this protection is permanent or temporary, and what happens to protected timelines when they outgrow the need for protection. Chapter 5. Infinite Branches. Hidden within the equations of quantum mechanics lies a possibility so vast and mind-bending that it reframes the entire time travel paradox. Every possible version of reality actually exists simultaneously in parallel. Universes and time travelers are missing from our timeline because they're revisiting infinite other versions of it instead. This is on speculation. It is a serious interpretation of quantum physics that suggests our universe is just one thread in an infinite tapestry of parallel realities. The concept begins with something called the many worlds interpretation, developed by physicist Hugh Everett III in the 1950s. According to this theory, every quantum measurement doesn't just collapse a wave function. It splits the universe into multiple parallel realities, each containing every possible outcome of that measurement. You experience only one outcome in your reality, but identical copies of you in parallel universes experience every other possible result. If this interpretation is correct, then the universe isn't a single timeline, but an infinite branching structure where every possible sequence of events actually occurs. At this very moment, there are versions of you reading these words in universes where time travelers openly walk among humans, where temporal technology is common, where historical events unfolded completely differently due to temporal interference. Dr. David Deutsch at Oxford University has developed the mathematical framework that shows how quantum parallelism could resolve the time travel paradox completely. In his calculations, time travel doesn't create paradoxes because it doesn't change the past within the same universe. Instead, it allows travelers to access parallel universes that resemble their past but exist as separate realities with their own independent causal structures. Think about what this means for your understanding of time travelers. They might exist in vast numbers, but they're distributed across infinite parallel universes rather than concentrated in your single timeline. For every universe where time travelers visit openly, there might be countless others where they remain hidden, and still others where time travel was never developed at all. You're reliving in what might be called a clean timeline, one of potentially infinite parallel realities that developed without detectable temporal interference. This doesn't make your reality less real or less important. It simply means that you're experiencing one specific thread in an infinite tapestry of parallel possibilities. The mathematics of quantum branching reveals something extraordinary about the structure of these parallel universes. According to quantum field theory, the number of parallel realities increases exponentially with time. Dr. Sean Cowell's calculations at Caltech suggest that the universe splits into approximately 1,086 new branches every second, each representing a different quantum outcome somewhere in the cosmos. This exponential branching means that the total number of parallel universes containing versions of you is literally infinite and growing at an incomprehensibly rapid rate. In this infinite collection of realities, every possible variation of your life is being lived simultaneously by different versions of yourself. Some of these parallel selves live in universes where time travelers are common and openly acknowledged. Others exist in timelines where temporal technology led to catastrophic paradoxes that destroyed civilization. Still others inhabit realities where the laws of physics are slightly different, making time travel impossible under any circumstances. The implications for time travel become clear when you understand that parallel universe travelers wouldn't be bound by the causality restrictions that prevent time travel within a single timeline. They could visit what appears to be their past because they're actually visiting parallel universes that resemble their history rather than their actual history. From their perspective, these visits wouldn't risk creating paradoxes because nothing they do in a parallel universe can alter their own timeline. They're free to interact with historical events, study ancient civilizations, or even prevent historical catastrophes, because their actions only affect the parallel reality they're visiting, not their original timeline. Recent research in quantum information theory suggests that these parallel universes might not be completely independent. Dr. Leonard Susskind's work on quantum entanglement indicates that information can be shared between parallel realities through quantum correlations that transcend the boundaries between universes. If parallel universes can exchange information through quantum entanglement, then time travelers might be able to gather historical data from parallel realities and bring it back to their own timeline without violating causality. They could study infinite variations of historical events across parallel universes, gaining unprecedented insight into how different choices and circumstances lead to different outcomes. This possibility transforms time travel from a method of changing the past into a tool for understanding the infinite variety of ways reality can unfold. Time travelers might exist not as historical tourists or paradox-creating interventionists, but as interdimensional researchers studying the vast library of parallel possibilities. Dr. Lisa Randall's work on extra-dimensional physics provides a framework for understanding how travel between parallel universes might be possible. Her calculations show that our three-dimensional reality might exist on a brane floating in higher dimensional space, with parallel universes existing on adjacent branes separated by microscopic distances and directions we can't perceive. If parallel universes exist in higher dimensional space, then sufficiently advanced technology might be able to engineer transitions between branes, allowing travelers to move from one universe to another. From our three-dimensional perspective, such travelers would appear and disappear without leaving our universe, making their presence nearly impossible to detect. The energy requirements for inter-universal travel would be enormous, but not necessarily impossible. Recent developments in string theory suggest that the barriers between parallel universes might be much thinner than previously thought, possibly requiring only the energy equivalent of a large particle accelerator to breach. This means that time travel to parallel universes might be achievable by civilizations only slightly more advanced than ourselves, explaining why we haven't developed the technology yet, but also suggesting that we might achieve it within the next few centuries. But the existence of infinite parallel universes creates its own disturbing implications for the nature of identity and consciousness. If there are infinite versions of you living in parallel realities, which one is the real you? Are you all equally real, or are you somehow special compared to your parallel selves? Dr. Derek Parfit's work in personal identity theory suggests that the concept of a unique self might be an illusion. If consciousness is simply the pattern of information processing in your brain, then all versions of you across parallel universes are equally real and equally you. You're not experiencing a single timeline. You're experiencing one perspective from an infinite collection of parallel selves. This perspective fundamentally changes the meaning of time travel. Instead of moving through time within your universe, time travelers might be shifting their consciousness from one parallel self to another, experiencing different versions of reality from the inside rather than visiting them as external observers. Recent experiments in quantum consciousness suggest that this kind of consciousness transfer might be theoretically possible. Dr. Roger Penrose's work on quantum processes in the brain indicates that consciousness might exist as a quantum field that extends beyond individual neurons, potentially allowing it to span multiple parallel realities simultaneously. If consciousness can exist across parallel universes, then you might already be a time traveler without knowing it. Your sense of continuity through time might actually be your consciousness shifting between slightly different versions of yourself in closely related parallel universes, creating the illusion of moving through a single timeline. The most recent developments in quantum cosmology suggest that parallel universe branching might not be random, but might follow patterns determined by the fundamental structure of consciousness itself. Dr. Henry Stapp's research indicates that conscious observation plays a crucial role in determining which quantum outcomes become realized in any given universe. If consciousness helps determine the structure of parallel universe branching, then time travelers might be able to navigate between realities by learning to consciously influence quantum processes. They might not need technology to travel between parallel universes. They might need only sufficient understanding of how consciousness interacts with quantum mechanics. This possibility suggests that advanced time travelers might exist as pure consciousness, capable of moving between parallel realities at will. They could be observing our timeline right now, but their presence would be undetectable because they exist as conscious entities rather than physical beings. As we explore deeper into the implications of infinite parallel universes, we discovered that the time travel paradox might be based on a fundamental misunderstanding of the nature of reality itself. Time travelers aren't missing from our timeline. They're distributed across infinite parallel timelines, each exploring different possibilities in the vast space of parallel realities. The question becomes not why we haven't met time travelers, but whether we might ourselves be time travelers exploring one specific thread in the infinite web of parallel possibilities, unaware that our consciousness is simultaneously experiencing countless other versions of reality across the parallel multiverse. Chapter 6. Observer effects. At the heart of quantum mechanics lies a principle so strange that even Einstein called it spooky. The idea that the simple act of observation changes the nature of reality itself. What most people don't realize is that this observer effect might be the key to understanding why time travelers seem absent from our timeline. The mathematics suggests something profoundly unsettling. The universe might be structured so that time travelers can only exist when no one is looking for them. The observer effect begins with the fundamental quantum principle that particles don't have definite properties until they remeasured. A quantum particle exists in what physicists call a superposition, a state where it simultaneously possesses all possible properties until the moment someone observes it, at which point it collapses into having specific, measurable characteristics. Dr. John von Neumann's mathematical formulation of quantum mechanics demonstrates that this collapse isn't just a quirk of small particles. It has a fundamental feature of reality at all scales. When scaled up to macroscopic systems like time travelers, the observer effect creates paradoxes that might make temporal visitors fundamentally undetectable. Consider what happens when you actively search for evidence of time travelers. According to quantum mechanics, the very act of looking for them changes the quantum state of any potential time travel event. If time travelers exist in a quantum superposition of detected and undetected states, then your observation might force them into the undetected state simply because you read looking for them. This creates what physicists call a quantum Zeno effect, the phenomenon where frequent observation of a quantum system prevents it from changing. If time travelers exist as quantum phenomena, then our constant searching for them might be preventing their detection by freezing them in an unobservable state. Recent experiments at the Vienna Institute of Technology have demonstrated the quantum Zeno effect on increasingly large scales. Researchers have shown that sufficiently frequent observation can prevent quantum systems containing billions of particles from evolving naturally. If this effect applies to time travel, then our civilizational obsession with finding time travelers might be the very thing preventing us from detecting them. Dr. Anton Zelling's work on quantum teleportation reveals another layer of the observer paradox. His experiments show that quantum information can be transferred instantaneously across any distance, but only if no one attempts to observe the information in transit. The moment someone tries to intercept or measure the quantum information, the teleportation fails. If time travel operates through similar quantum mechanisms, then time travelers might be able to move through time only as long as no one in their destination timeline is actively searching for evidence of their presence. Our scientific investigation into time travel might be creating a kind of temporal uncertainty principle, where the more precisely we try to detect time travelers, the less likely they are to appear. The mathematics of this principle come from the work of physicist Max Tegmark at MIT, who has shown that conscious observation creates irreversible changes in the quantum structure of reality. If time travelers exist as quantum phenomena that depend on not being observed, then the development of scientific civilization itself might create an exclusion zone around our timeline that prevents temporal visitors from manifesting. This leads to a deeply disturbing possibility. Primitive civilizations might be routinely visited by time travelers, but as soon as those civilizations develop enough scientific sophistication to look for temporal visitors, the observer's effect automatically hides them. You might be living in a universe where time travelers were common throughout most of human history, but disappeared the moment we became scientifically advanced enough to detect them. Dr. Roger Penrose's work on objective reduction suggests that consciousness plays a fundamental role in collapsing quantum wave functions. If time travelers exist as conscious entities operating in quantum superposition, then the presence of observers, people like you who are conscious and looking for them, might force their wave functions to collapse into undetectable states. This creates what researchers call the consciousness exclusion principle. Highly conscious, scientifically sophisticated civilizations automatically become unvisitable by time travelers because the collective consciousness of such civilizations creates quantum effects that prevent temporal phenomena from manifesting. The implications extend beyond simple detection to challenge our understanding of historical events themselves. If time travelers were routinely present during pre-scientific periods of human history, they might be responsible for various historical mysteries that we currently attribute to human ingenuity or natural phenomena. The construction of megalithic structures like Stonehenge or the pyramids, the sudden appearance of advanced mathematical knowledge in ancient civilizations, the mysterious disappearances of entire cultures. These events might be the fingerprints of time travel activity that was possible only because the people of those eras lacked the scientific consciousness necessary to prevent temporal visitation. Recent research in collective consciousness suggests that the observer effect might operate not just on individual consciousness, but on civilizational awareness as a whole. Dr. Dean Radin's experiments with global consciousness events indicate that major world events create measurable changes in random number generators worldwide, suggesting that collective human attention has quantum effects that extend beyond local observation. If collective consciousness can influence quantum phenomena on a global scale, then the simple fact that millions of people are now aware of the possibility of time travel might be creating planetary scale observer effects that prevent any temporal visitation from occurring. You are not just an individual looking for time travelers. You are part of a collective consciousness that has become so aware of the possibility of time travel that your species' collective observation might be preventing it from manifesting in your reality. The mathematics of quantum decoherence provide another framework for understanding how observation might exclude time travelers. Dr. Wojciech Zurek's work shows that interaction with environmental systems causes quantum superposition to break down, forcing quantum systems to behave according to classical physics. If time travelers depend on maintaining quantum coherence across time, then existing in a universe filled with conscious observers might cause their quantum states to decohere, effectively stranding them in their original timelines. They might be able to travel to uninhabited regions of space or to prehistoric Earth before the emergence of consciousness, but they cannot visit any time and place where conscious observation would destroy their quantum coherence. This suggests that Earth's development of intelligent life might have automatically created a temporal exclusion zone around our planet that prevents time travelers from accessing any period after the emergence of consciousness. They might be able to observe our timeline from a distance, but they cannot enter it without losing their ability to return to their own time. Perhaps most unsettling is the possibility that the observer effect operates retroactively through time. Some interpretations of quantum mechanics suggest that future observations can influence past quantum events through what physicists call retrocausality. the idea that effects can precede their causes at the quantum level. If retrocausality applies to time travel, then your current search for evidence of time travelers might be reaching backward through time to prevent temporal visitation from occurring throughout history. The simple fact that you rereading these words might be creating quantum effects that cascade backward through time, ensuring that time travelers never appeared at any point in human history. Dr. Yakir Aharonov's work on two-state vector formalism provides mathematical support for this possibility. His calculations show that quantum systems can be influenced by both past and future boundary conditions, creating what he calls quantum time symmetry. If consciousness participates in these time-symmetric quantum effects, then conscious civilizations might automatically edit their own timelines to exclude paradox-creating phenomena like time travelers. The observer effect might also explain why time travel seems to be theoretically possible according to physics, but practically absent from our experience. The laws of physics allow time travel under certain extreme conditions, but the presence of conscious observers might prevent those conditions from ever being realized in practice. Advanced civilizations attempting to build time machines might find that their devices simply refuse to function as long as conscious beings are present to observe them. The technology might work perfectly in theoretical calculations and computer simulations, but fail every time someone tries to test it in reality, because the act of observation prevents the quantum conditions necessary for time travel from stabilizing. Recent experiments in delayed choice quantum eraser scenarios suggest that the observer effect can operate across arbitrarily large distances and time intervals. If these effects apply to time travel, then the mere existence of conscious civilizations anywhere in the universe might create observer effects that prevent time travel from functioning anywhere in the cosmos. This would explain not just the absence of time travelers in our timeline, but their absence throughout the observable universe. Every sufficiently advanced civilization would discover the same frustrating reality. Time travel remains forever tantalizingly out of reach, not because of technological limitations, but because consciousness itself prevents the quantum conditions necessary for temporal displacement. As we explore deeper into the implications of quantum observation, we uncover a reality where consciousness and time travel exist in fundamental opposition to each other. The universe might be structured so that you can either have conscious observers or time travelers, but never both simultaneously. The question becomes whether this exclusion is temporary. Perhaps consciousness and time travel can coexist under conditions we haven't yet discovered, or whether it represents a fundamental feature of reality that makes time travel forever impossible for conscious beings like ourselves. Chapter 7. Energy constraints. Behind every theoretical time machine lies a hidden truth that physicists rarely discuss in public. The energy requirements for practical time travel are so staggeringly enormous that they challenge our understanding of what's possible within the laws of physics themselves. We're not talking about the power requirements of spaceships or particle accelerators. We're talking about energy scales that rival the output of entire galaxies. And the implications might explain why time travelers remain conspicuously absent from our timeline. The energy problem begins with Einstein's general theory of relativity, which describes gravity as the curvature of spacetime caused by mass and energy. To create the kind of spacetime curvature necessary for time travel, what physicists call a closed timelike curve requires manipulating the fundamental structure of reality itself. Dr. Kip Thorne's calculations at Caltech demonstrate that creating a traversable wormhole large enough for human passage would require approximately 1,064 joules of energy. To put this in perspective, this is roughly equivalent to the total energy output of our Sun over its entire 10 billion year lifetime, concentrated and applied in precisely controlled ways to warp spacetime into the specific configuration needed for temporal displacement. But even more exotic is the type of energy required. Stable time travel doesn't just need enormous amounts of ordinary energy. It requires what physicists call exotic matter, with negative energy density. This isn't simply matter with less energy than expected. It's matter that possesses less energy than completely empty space itself. Dr. Lawrence Ford's research on quantum field theory shows that extracting significant amounts of negative energy from the quantum vacuum would require technology capable of manipulating the fundamental quantum fluctuations that permeate all of space. The engineering challenges are mind-bending. You would need to create regions of spacetime where the quantum vacuum itself has been modified to produce energy, densities lower than nothingness. Recent calculations by physicist Van den Broek suggest that even the most optimized wormhole design would require exotic matter equivalent to the mass energy of Jupiter, but with negative energy density. Creating even tiny amounts of stable negative energy appears to require particle accelerators larger than solar systems, operating for timescales comparable to the age of the universe. The quantum inequalities discovered by Ford and Raman impose even more severe limitations on exotic matter production. These mathematical theorems prove that the amount of negative energy that can be extracted from the quantum vacuum is fundamentally limited by the laws of quantum mechanics themselves. The more negative energy you try to extract, the more unstable spacetime becomes, until the vacuum itself undergoes catastrophic collapse. This creates what physicists call the energy paradox of time travel. The amount of negative energy required for practical time machines appears to exceed the maximum amount that quantum mechanics allows to exist in any finite region of spacetime. You can't build a time machine because the universe's energy bookkeeping system prevents you from accumulating enough exotic matter to power one. But recent discoveries in dark energy research suggest an even more profound problem with time travel energy requirements. Dark energy, the mysterious force accelerating the expansion of the universe, represents roughly 68% of the total energy content of the cosmos. If time travel requires manipulation of space-time curvature on cosmic scales, it might require access to and control over dark energy itself. Dr. Adam Rees's observations of distant supernova suggest that dark energy operates according to principles we don't yet understand, with properties that seem designed to prevent precisely the kind of space-time manipulation that would be necessary for time travel. The universe's expansion appears to be driven by a form of energy that actively resists the formation of closed timelike curves. The mathematical framework of string theory provides another perspective on time travel energy constraints. According to string theorists like Brian Greene, our four-dimensional spacetime might be embedded in a higher dimensional structure with up to 11 total dimensions. Time travel might require manipulating these extra dimensions in ways that demand energy comparable to the Planck scale, the energy density at which quantum mechanics and general relativity break down entirely. Operating at Planck scale energies means dealing with conditions where individual particles carry as much energy as macroscopic objects, where spacetime itself becomes quantized and discontinuous, and where the distinction between matter and energy loses all meaning. Building technology capable of functioning under these conditions might be impossible even for civilizations millions of years more advanced than ourselves. Dr. Stephen Hawking's research on black hole thermodynamics reveals another layer of the energy problem. According to his calculations, creating a stable time machine might require precisely balancing enormous gravitational forces while preventing the formation of an event horizon that would trap the time travelers inside a black hole. This balancing act becomes increasingly difficult as the energy requirements increase. At the energy levels required for practical time travel, tiny fluctuations in the power supply would either collapse the time machine into a black hole or cause it to explode with the force of multiple supernova. The engineering precision required exceeds anything possible with matter-based technology. Recent advances in quantum gravity theory suggest that the energy constraints might be even more fundamental than previously understood. Dr. Carlo Rovelli's loop quantum gravity calculations indicate that space-time itself has a granular structure at the Planck scale, composed of discrete atoms of space and time. If space-time is fundamentally granular rather than continuous, then time travel might require manipulating individual atoms of space-time, an engineering challenge comparable to performing brain surgery by controlling the motion of individual quarks. The energy required to manipulate space-time at this fundamental level might be physically impossible to generate or control using any conceivable technology. The thermodynamics of time travel create additional energy problems that researchers rarely discuss. According to the second law of thermodynamics, entropy must increase in isolated systems. Time travel potentially violates this law by allowing information to flow from high-entropy futures to low-entropy pasts, effectively decreasing the total entropy of the universe. Dr. Leonard Susskind's work on the holographic principle suggests that preventing entropy violations might require the universe to expend enormous amounts of energy, maintaining what he calls causal consistency. Every time travel event might automatically trigger cosmic-scale energy expenditures as the universe corrects for entropy violations, making time travel prohibitively expensive from a thermodynamic perspective. Perhaps most significantly, recent research in quantum information theory suggests that time travel might require not just enormous amounts of energy, but impossible amounts of information processing. Dr. Seth Lloyd's calculations at MIT indicate that simulating the quantum state of even a small region of spacetime requires computational resources that exceed the information processing capacity of the entire observable universe. If time travel requires precise control over quantum states in curved spacetime, then information processing demands alone might make it impossible for any finite civilization to achieve, regardless of their energy resources. The universe simply doesn't contain enough matter to build computers capable of calculating the quantum dynamics necessary for stable time travel. The cosmic microwave background radiation provides additional evidence for energy constraints on time travel. Recent observations by the Planck satellite show that the early universe possessed precisely the energy density necessary for the formation of stars, planets, and life. If time travelers were routinely extracting enormous amounts of energy from the cosmic energy budget, these observations suggest that such extraction would have prevented the universe from developing the conditions necessary for our existence. This creates what physicists call the energy conservation paradox. If time travel is possible and commonly practiced by advanced civilizations, then the total energy available for normal cosmic evolution would be drastically reduced, making the formation of new civilizations impossible. The universe appears to be structured so that widespread time travel would be self-defeating, preventing the development of the very civilizations that would eventually invent it. Dr. Juan Aldacina's work on the ADS-CFT correspondence suggests that the energy constraints might be even more fundamental than individual time travel attempts. His calculations indicate that the maximum amount of information that can be processed in any finite region of spacetime is fundamentally limited by that region's surface area rather than its volume. If time travel requires processing information about the entire history of the universe to avoid paradoxes, then even civilizations with access to the energy output of entire galaxy clusters would lack the computational resources necessary to ensure safe temporal displacement. The energy constraints of time travel might represent one of the most profound barriers in the universe, a limitation so fundamental that it prevents any civilization, regardless of technological advancement, from achieving practical mastery over time. The absence of time travelers in our timeline might not reflect the rarity of advanced civilizations or the impossibility of time travel in principle, but rather the absolute impossibility of generating and controlling the energy required to make it work in practice. As we'll discover, these energy barriers might be just one component of a larger cosmic system designed to prevent temporal paradoxes through mechanisms so sophisticated that they operate automatically at the level of physical law itself. Chapter 8. Selection Pressure. Hidden within the evolution of consciousness itself lies a mechanism so subtle and profound that it might explain why time travelers remain absent from our timeline. Civilizations that develop time travel technology automatically select against their own survival through temporal paradoxes, while civilizations like ours that haven't yet developed such technology survive precisely because we lack the ability to accidentally erase ourselves from existence. This concept begins with a dark understanding of what happens to civilizations that gain unrestricted access to their own timelines. Unlike the energy barriers or quantum constraints we've explored, selection pressure operates through the far more insidious mechanism of evolutionary extinction. Civilizations that master time travel don't vanish because it's impossible, but because they inevitably use it in ways that eliminate themselves from existence. Dr. Nick Bostrom's research on existential risks provides a framework for understanding this selection mechanism. According to his analysis, sufficiently advanced technologies inevitably present civilizations with what he calls great filters, technological developments that dramatically increase the risk of self-extinction. Time travel represents perhaps the ultimate great filter because it allows civilizations to accidentally eliminate not just their current existence, but their entire historical development. Consider the mathematical implications of unrestricted time travel for civilizational survival. Every modification to the past creates branching probability cascades that affect millions of subsequent events. Even tiny changes, preventing a specific marriage, altering the outcome of a minor historical event, or accidentally introducing anachronistic knowledge, can propagate through history to prevent the eventual development of the time-traveling civilization itself. Dr. Edward Lawrence's work on chaos theory demonstrates that these propagation effects are not just possible, but inevitable. His famous butterfly effect calculations show that microscopic changes to initial conditions can produce dramatically different outcomes across complex systems. When applied to civilizational history, this means that any time travel intervention, no matter how carefully planned, creates unpredictable cascade effects that could easily eliminate the civilization that initiated them. The selection pressure operates through what physicists call the temporal suicide principle. Civilizations that develop time travel technology inevitably experiment with it, and civilizations that experiment with temporal manipulation inevitably trigger paradoxes that erase their own timelines from existence. Only civilizations that never develop time travel technology survive long enough to wonder why time travelers don't visit them. Recent research in complexity theory suggests that this selection mechanism operates automatically without requiring conscious decisions by time-traveling civilizations. Dr. Stuart Kaufman's work on autocatalytic networks shows that complex systems naturally evolve towards states of maximum instability when given access to their own causal foundations. A civilization with time travel technology gains the ability to modify its own causal foundations, the historical events and decisions that led to its development. According to Kaufman's mathematics, any system with this capability will inevitably explore modifications that destabilize its own existence, not through malicious intent, but through the natural tendency of complex systems to explore all available possibility spaces. This creates what researchers call temporal natural selection. The universe is filled with countless civilizations that develop time travel technology, but they systematically eliminate themselves through temporal experimentation, leaving only civilizations like ours that haven't yet reached the point of temporal self-destruction. Dr. Robin Hansen's analysis of the Great Silence, the conspicuous absence of detectable alien civilizations, suggests that technological civilizations face multiple extinction filters throughout their development. Time travel might represent the final and most deadly filter, eliminating even those civilizations sophisticated enough to survive nuclear weapons, artificial intelligence, nanotechnology, and other existential risks. From this perspective, the absence of time travelers becomes a positive indicator that humanity might be following a survival trajectory. We haven't met time travelers because the civilizations that develop time travel don't survive long enough to visit us, while civilizations that do survive are those that, like us, haven't yet crossed the temporal extinction threshold. The mathematics of temporal paradox resolution provide another layer of understanding for this selection pressure. When physicists model the resolution of temporal paradoxes, they discover that the most common resolution involves eliminating the causal chain that created the paradox in the first place, including the civilization that initiated the time travel attempt. Dr. John Wheeler's work on delayed choice experiments suggests that the universe possesses retroactive consistency mechanisms that automatically eliminate paradoxes by editing the past to prevent them from arising. If these mechanisms operate on civilizational scales, then any attempt at time travel would automatically trigger cosmic editing processes that remove the time-traveling civilization from existence. The selection pressure might operate not just through accidental paradoxes, but through the psychological effects of temporal knowledge itself. Civilizations that develop time travel gain access to knowledge about their own futures, including potential extinction events, technological dead ends, and civilizational failures. This future knowledge creates what psychologists call prophecy paralysis, the tendency for knowledge of future events to prevent event actions necessary to achieve positive outcomes. Civilizations might become extinct not through temporal accidents, but through the psychological breakdown that results from too much knowledge about their own futures. Dr. Daniel Kahneman's research on decision-making under uncertainty suggests that access to perfect information about future outcomes can actually impair decision-making by overwhelming cognitive systems designed to operate under conditions of partial uncertainty. Civilizations with time travel might literally think themselves to death by becoming paralyzed by their knowledge of all possible futures. Recent studies in evolutionary psychology suggest that consciousness itself might have evolved specifically to operate under conditions of temporal uncertainty. Our ability to plan, hope, and maintain motivation depends on not knowing exactly what will happen in the future. Civilizations that eliminate temporal uncertainty through time travel might inadvertently eliminate the psychological foundations that make conscious life worth living. The selection pressure extends beyond individual civilizations to affect entire cosmic regions. If time travel allows civilizations to modify the past throughout their local cosmic neighborhoods, then regions of space that contain time-traveling civilizations become increasingly unstable over time, eventually becoming so paradox-ridden that no stable civilizations can exist within them. This creates what cosmologists call temporal dead zones, regions of space where time travel activity has made stable historical development impossible. The observable universe might be structured so that we exist in a temporal preserve, isolated from regions where time-traveling civilizations have destabilized the causal structure of space-time itself. Dr. Max Tegmark's research on the anthropic principle suggests that we should expect to find ourselves in a universe where our observations are possible. If time travel inevitably leads to civilizational extinction, then conscious observers should expect to find themselves in timelines where time travel hasn't yet been developed, because these are the only timelines where observers can exist. This anthropic reasoning explains why we haven't met time travelers in a profoundly unsettling way. We exist in a reality where time travelers are absent, precisely because realities with time travelers are uninhabitable by conscious observers. We're not in a timeline that happens to lack time travel. We're in one of the only types of timelines where conscious observation remains possible. The implications extend to our own future development. If the selection pressure theory is correct, then humanity faces a stark choice: develop time travel technology and risk immediate extinction through temporal paradox, or deliberately avoid temporal research and remain forever ignorant of our ultimate temporal capabilities. Recent developments in artificial intelligence add another dimension to this selection pressure. AI systems with access to time travel might be immune to the psychological breakdown that affects biological civilizations, but they would face their own forms of temporal selection pressure through recursive self-modification across timelines. An AI that travels back in time to modify its own programming creates the possibility of infinite recursion loops where it repeatedly alters its own development, potentially becoming trapped in cycles of self-modification that prevent it from ever achieving stable temporal control. The most recent research in quantum biology suggests that consciousness itself might be fundamentally incompatible with knowledge of absolute temporal relationships. Dr. Roger Penrose's work on quantum processes in the brain indicates that conscious awareness depends on quantum uncertainty in neuronal microtubules. If consciousness requires temporal uncertainty to function, then civilizations that achieve perfect temporal knowledge through time travel might automatically extinguish consciousness within their populations, becoming unconscious automata that can manipulate time but lack the awareness to appreciate or direct their capabilities. As we explore the implications of temporal selection pressure, we discover that the absence of time travelers might not be a puzzle to solve, but a cosmic safety mechanism that ensures the survival of conscious observation itself. We haven't met time travelers because meeting them would indicate that we exist in a reality where consciousness is about to become extinct. The question becomes whether this selection pressure is absolute, or whether there might be pathways to temporal mastery that allow civilizations to transcend the extinction filter while maintaining the conscious awareness that makes existence meaningful.